Well, thanks for joining me today. Can you start with telling us your name and what do you do?
I'm Carsten Bormann. I'm with the University of Bremen in Germany, and I work on Internet technologies and recently the Internet of Things.
You know what I'm interested in talking about today is standardization. Can you explain the three layers of standardization in the Internet of Things?
In the Internet of Things, we first of all have to get data off the devices, which may be in remote locations, hard to reach, blasted into the wall. So we need something like a wireless interface to talk to those devices. Then at some point we have to aggregate all the data from the various wireless devices. We have to do some networking to get them to the place where they actually are needed. And of course, once we can have all the devices talk to each other, the next question is, what do they talk to each other? So we need an application protocol.
Okay. So the first layer, so layer one is going to be at the, let's say, the media layer. Layer two is going to be at the communication or protocol layer, networking layer. And then layer three is at the application layer.
Right.
Okay. And can you give us just maybe, just some high level, I guess, understanding of what's happening at each of the three layers?
So at the media layer, we have a number of solutions because we just have different technical characteristics we want to do. There's a big difference whether I'm talking from my phone to my shoe or whether I'm talking from one end of the airport to the other end. So there are just different technical solutions, there are different spectrum availabilities and so on. So we have half a dozen to a dozen different wireless technologies and a few wire technologies we would be using for attaching sensors.
Can you give us some examples?
So, for instance, in the building automation environment, the Zigbee set of standards has been used for a while. That is a complete stack, but there is a radio in there, which is the 802.15.4 IEEE standard, and that can be connected to IP using the 6LoWPAN adaptation layer.
Right. And then on the next layer up, then what are some examples there?
So 6LoWPAN is the adaptation layer. So in the end, we can transmit and receive IPv6 packets over that, but we also have to look a little bit at the amount of data we actually send, because those sensors might be operated from primary batteries, which have to last maybe 2, 3, 5 years. So we have to be very power efficient. Right. So we have to work a little bit on adapting the IP protocol to that kind of situation.
And what are some of those adaptations then?
So for the various wireless standards we have adaptation layers which come together in the 6Low family of standards right now. 6LoWPAN was the first. It's addressing the wireless personal area network. Getting it on the radio so it can efficiently be used. Right, the 802.15.4, and then we got other adaptation layers for instance Bluetooth and the Z-Wave radio. Again, Z-Wave is a whole stack, but the Z-Wave radio is rather popular, and other radios that are of interest, like the DECT digital cordless telephone standard, which is interesting because it has its own spectrum. So it's not interfering with other devices, and all of these need a little bit of additional glue to map them to IP. And where does
6TiSCH come in the thing?
So 6TiSCH is an interesting idea. The original 802.15.4 radio often was just used on a single frequency, and the problem with a single frequency is that when you have any kind of interference or path problem, reflections and so on, it's going to sit on that frequency and make your connection bad. So you want to do frequency hopping, and 6TiSCH allows several devices to do frequency hopping and stepping through the frequency spectrum without stepping on each other.
Okay. Let's move up again now on the application layer. What's the standards that we're finding today?
So much of the internet today works on HTTP. And there is an underlying architecture which is called representational state transfer, or REST. You can use HTTP, that works, But it does require a lot of resources. An HTTP request might be 500 bytes, and that might be 4 packets in one of these wireless radio standards. And to reduce the amount of data that needs to be sent, because that costs a lot of energy, you want to use a much more concise protocol.
Okay.
One could compress HTTP, but you still have a lot of baggage with that. So the idea was just to start with a clean sheet and look at building an application protocol that does most of what HTTP does, but does it in a very concise, very basic, efficient way. And that protocol has been created in the last 3 years, and that's the Constrained Application Protocol, or COAP for short.
Is the standardization, and I guess you have to take this on a layer by layer point of view, but is the standardization far enough along now that you feel that it's solid? I mean, is there going to be anything else coming, or is what's there standard enough? Maybe you can talk us through, each layer, kind of where it is evolutionary, from an evolutionary point of view, and where I'm really coming from this is from a developer point of view, a company point of view. Should I rely on the standards today, or do I need to wait for them to solidify a little bit more?
Right. On the media layer, you can buy the chips, so the standards are there, and the adaptation layers we need are done for many of them. Some of them are still moving, like the DECT ultra low energy standard. That is just being completed right now. But there is a set of solutions for a number of wireless technologies you can choose from. On the application layer, the COAP standard was approved last year. So that has been out. A number of additional documents are being worked on and are in various stages of finishing, but that hasn't stopped other people like the Open Mobile Alliance to actually go ahead and build something they call the lightweight machine-to-machine standard, using those elements. And that's actually quite a good way to enter the world of COAP, because they selected certain functionalities, built it into a standard that solved their problem, and you can just take this standard and build systems that work today.
All right, well, there it is, from the source. This is the state of the art of standardization IoT. Thank you very much, Carsten.
Thank you.